Alright, a quick video to answer a question that came up about a question from 5.2, 5.2 number 24. The question has to find relative extrema, so local maxes and mins, for a function f given by x to the sixth times e to the x minus 3. So the routine is basically compute the derivative, find critical points or critical values, and then classify those critical values as extrema or not extrema. So in the beginning, finding the derivative, there is a product rule involved in this. So I need to take the derivative of x to the sixth times e to the x plus e to the x times plus x to the sixth times derivative of e to the x. And here's my derivative. It's pretty simple looking. It's 6x to the fifth e to the x plus x to the sixth e to the x. So that's the first stage, is computing the derivative of the function. Second stage is looking for critical values, and so those are going to come up when the derivative is equal to 0 or undefined. In this case, the derivative is defined everywhere, so I just look for where the derivative is equal to 0. So set it equal and solve. A good thing to remember is when you use the product rule to compute a derivative, look to try to factor to help you find out where it's equal to 0. So notice these two terms have a common e to the x and x to the fifth, and that's what comes out. And so this splits now into x to the fifth is 0, e to the x can't be 0, so don't worry about that factor. And 6 plus x equals 0 gives us x equals minus 6. And so I've got these two critical values, and now we look to classify them. And so I use something called the first derivative test to classify them. And so in order to do that, I build a little picture of the number line. And this is keeping track of the signs of the derivative f prime of x. What happens outside of what happens inside of the intervals created by the minus 6 and 0 endpoints. So I plug in a test point like -7 and see that the derivative up here would be positive when I plug that in. Plug in like -1, something between those values, to see the derivative would be negative in between and positive on the other outside. So basically, derivative is positive means the function's going up, increasing. Derivative is negative, it goes down, decreasing. So you can see we have a hump. We have like a local maximum at -6, f of -6. Now remember to plug it back into f, not f prime, to figure out the y value there. Similarly, going from negative to positive with the derivative, it's decreasing function to increasing function. And we have a local minimum there, a relative minimum at 0, f of 0.